So I guess while we're waiting, do we have some volunteers to take minutes?
I can help.
Thank you. Can we get a second volunteer? Usama's going to be speaking for part of it. Okay, so if you're just joining, we are going to be having a virtual interim of the Remote Attestation Procedures meeting, or RATS. Thank you everyone for joining. Just a bit on the Notewell. So this is the Notewell describes the guidelines for participation, so please be familiar with what they are. I'm not going to go through them in detail. Code of conduct, just a few reminders. You know, it's in the details in an RFC, but just so we're all on the same page, be respectful, have a personal discussion. Remember that we're working for the broader goals of the internet, and look forward to your contribution. We have one notes taker. We still need a second notes taker, someone who can do that. That would be very much appreciated. Did I hear a volunteer?
I can do that.
Okay, thank you, Zane. And we're getting a bunch of microphone noise from you, I think, as well. All right. Anything else? I think that's it. The agenda. We have 3 items on the agenda, plus some open mic time. So, well, first up on the agenda is a EAT profile for device assignment. This is Matthew and/or Thomas are presenting that. So we will just, unless there's other questions or agenda bashing, I'm going to jump into the presentations. So speak up if you have anything here as far as the agenda goes.
Hello.
Okay. So
everyone, yeah. So this is a presentation that Mathieu was supposed to deliver, but he unfortunately caught a bug or something, and so he cannot present today. So I'm taking this on, but the handover was quite rushed, so I cannot guarantee the quality of the final result. But, so apologies in advance. This is a quick presentation of an individual draft that Mathieu and I have been working on for the past, I would say, 6 months or so. And the overall goal here is to describe devices like GPUs or storage or MPUs or whatever that are connected to a confidential virtual machine, a CVM, of course in a confidential computing environment. And since these devices become part of the CVM trust boundary, once they are accepted, they may need to be represented to an external verifier. And this draft, what it does is create an overall EAT profile that describes these devices in terms of the relevant trust metrics, measurements, identity, and whatnot. So next, please. All right, context. Yeah. So the context. The context is that one or more devices have been assigned to a given CVM, and claims related to these devices are collected somehow and exposed to user land via some kind of kernel ABI Could be SysFS, could be netlink based. It doesn't matter. There's a way that the kernel pushes this information to userland. And in userland, you have an agent that sits within the CVM, which uses this ABI, pulls from this ABI and collects the measurements. And what it does, it repackages them into this EAT profile format. And then what it does, it binds them with the rest of the evidence material, right, associated with the platform, the CVM, and whatnot. And this repackaging happens, in some kind of composite evidence format, maybe a collection CMW, maybe an EAT with submods or something else. And once that thing is repackaged, it's sent over to the verifier for inspection. Next, please. So the problem is that we have that there are many types of devices and many architectures. Confidential computing architecture here, talking about. And this is, of course, a perfect combo for combinatorial explosion, right? Therefore, what we aim at is minimizing the complexity, which, short of sort of hiding this information from the outside world completely, means you need to find a uniform and architecture agnostic way to represent this stuff. And of course, as I said before, on top of that, we want to be able to bind this information to the wider CVM context to which the devices are associated, so the platform evidence, etc. Next, please. So, so the guiding principle here is, simplify and standardize. This way we avoid exposing too much of the gory details that are not necessary to a verifier for taking the trust decision based on evidence, right? And also we eliminate the need for specialized parsing logic on the verifier, but also potentially on the underlying party end. And we have started building around the SPDM TDISP standard, which are primary use cases for us in the context of RMCC prototyping work that we do. But I think, this is the current standard for this kind of stuff, for trustworthy device assignment. So it seemed like a natural place where to start. Next, please. So we have this draft out. It's pretty short, and the bulk of it is in fact a bunch of CDDL files that describe the data model that we want to represent. Here's a couple of links to the GitHub where the editorial and issue tracking activities taking place, and the data track entry for this, which is an individual draft. Still, we don't want to ask for adoption at this time. We need more time to look at various aspects. Maybe I can go deeper later on. But this work was presented in the context of other confidential computing relevant fora, CCC Attestation SIG, CCC kernel SIG, Linux Plumbers, the confidential computing dev room, and we have been talking to people in the Linux community quite a lot, and especially based on their input, we have made changes to the document, which resulted in 5 revisions, which were effectively based on the feedback that we collected from them. Next, please. So the data model, as I said, there's an overall EAT claim set, which we call DAT. Actually, Hank called it DAT. It was called differently before, but he decided this was a more catchy name, and it is with a profile, which as of now is a linaro.org thing, but you know, eventually it will change. It will morph into something more standard. It has the usual nonce, of course, for dealing with the freshness and binding with the outer token parts. And then the interesting bit is the each submod claim that has one device-specific claim set for each of the devices that have been attached to this CVM. So there's also, we describe also a naming convention for the device name so that they are unique within the map. And then for each of the names corresponds to an associated claim set, which could be one of the four specified below. At the moment, we have SPDM and PCIe legacy, completely described. We are aiming for CHI and CXL, which are other bus technologies, which may come a bit later. We don't know yet, but you know, the thing is, the thing to grasp here is that the device claim set is an extensible thing. So bus technologies that may pop up in the future can just plug their claim set here and be done with it. So next, please. All right, yeah, so, okay, so this is not especially confidential computing related, but it's just the PCIe legacy config space that we dump as is in the PCIe type config space bytes, or broken down into a more readable map in the text version. Nothing very interesting here related to confidential computing, so we can maybe move on. Thank you very much. This is instead the SPDM claims map with its own profile, of course, and then the SPDM artifacts as measurements and certificate, measurements only or certificate only. Plus an optional VCA, the version capabilities algorithm preamble of the SPDM conversation between requester and responders, which could be dumped here in case you need it for, you know, debugging reasons or whatever. Next, please. And drilling down into the specific data types of the certificates, which is of course the as per SPDM specification, this is the certificate chain associated with the device, which is mandatory in slot 0, and then a number of optional cert chain that the vendors or integrators or whoever can populate with their own cert chain, optionally, of course. The cert chains are encoded as just ASN1 there encoded certificates that are just smashed together without intermediate padding. The other thing that we model is the measurement, of course. And so it's a map with a block ID identifier and the associated SPDM measurement. So block IDs are, I think, 256, but lots of them are already reserved. So you end up with 239 block IDs that are available. Plus, we add an optional signature in case you want to see the full transcript of the conversation between responder and requester. Next, please. We can look into the measurement, and if you're familiar with SPDM, you'll notice that this is effectively the representation of what goes on the wire there. So you have the component type, which is a set of code points that identify specific types of components, mutable ROM, mutable firmware, etc., config space, blah, blah, blah. And on the other end, you have a component type, which is either a digest or a row measurement. You can have one or the other. Yeah, next, please. And this is the optional measurement block signature in case you want to see the whole thing, the gory details. with the two nonces and the concatenation of the messages and the signature itself and the hash algorithm and whatnot, so that the verifier on the other end of the wire can actually recompute the whole thing and verify that the signature was correct, and using the certificate in the search chain, make sure that that the signature anchors onto a known verifier, a known vendor. Sorry. Next, please. What else is on the table? So, as I said before, we are currently supporting PCIe legacy and the SPDM TDISP kind of devices. Other bus technologies are working there, CXL and CHI. But as I said before, this could be handled separately. Each claim set is effectively a standalone thing, which is its own profile with its own profile. So in theory, one could plug in stuff into the framework at a later point in time. Another thing we wanted to do, which seems very useful, would be add a description of how this token can be bound together with a platform token. In our case, since we're working on CC architecture, it's going to be the CC attestation token, but what we would like is that other architectures, if interested in this format, of course, would provide similar text. Next, is there any slide next? Open questions, okay. There are a few open questions. Again, what is this? How to keep up with upcoming version of the SPDM specification? Yes, of course. So here we are dealing with SPDM, I think 1.3 onwards. But what happens if, question is, what happens if SPDM breaks backwards compatibility in the future? And I think the answer is we move the profile. We change the profile name. Another question that was raised at least a couple of times at Plumbers was whether, apart from SPDM, it would be interesting to also convey TDISP artifacts. And at the first pass, it seemed that the answer was no, but then there are maybe, because this is really very detailed stuff that it's hard to imagine how a verifier could actually make sense of that. But there are some bits that might be interesting in terms, for example, of updating the firmware live. That might be an interesting thing to expose. We'll see. And the other open question is for the audience is whether you would be able to use the specification, and if not, we'd be very interested in understanding what needs to change in order for the technology to be relevant to you. Thanks very much. Ned, you are in the queue?
I'm in the queue. So, yeah, I guess several questions, but I guess the high-level question is, who needs this information? Why are we delivering it to a verifier?
Because it's part of the TCB. So a verifier might want to have a full picture of the TCB of the CVM, including whatever device happens to be attached to it. That's the thinking. Mm-hmm. Mm-hmm. There are, of course, other situations where you want to hide that, right?
Okay, so the next question then is, I think you've sort of captured as open, given that it's a lot of what you're describing is sort of a CDDO representation of structures that are defined by other standards groups and need to track them over time. Is this the right place for that work to happen, or should it move to those respective groups?
I think once we establish the framework, the specific of each device claim set can be moved to that specific group. So if PCI SIG wants to define their own new stuff, or another org has a stake in the game, and it should be very easy, right? So because what you need to do is mapping your stuff onto CWT and JWT claims. So in my view, this is something that other organizations should handle.
So okay, so just to, I don't want to go too deep on it. But basically, why the question is around where's the right place to stop in terms of rats versus pick it up in one of the other standards bodies. It seems like if rats just defined sort of the extensible type for what comes next, that's good enough. And if somebody else wanted to write the rest of the CDDL for the TDIS specific or SPDM specific content, they certainly can do that, and they could do it in a way that maintains consistency with whatever their spec release schedule is. It seems like it'd be much easier to manage if you did it that way.
I agree with you. Yes.
So SPDM is with the DMTF, correct?
Correct.
Yes. Carl?
I left a comment, just a minor point on your mention of concatenating certs. I would suggest you use either a certs-only signed data or a sequence of certs, so you can use regular DIR decoding tools to deal with that.
Thanks very much for the suggestion. I will note this down. Thanks a lot, Carl.
Okay, any other questions? Usama.
Yeah, one high-level question is that I view it kind of as in my understanding, what you're trying to do is basically have a device which is attached to the CVM. And following up on what you responded to Ned in the beginning, like the reason you want to give it to the verifier or to the relying party is that it is a part of the TCP. And I'm trying to understand that who owns the keys in this case for that specific device, like the platform and the CVM both have the keys for that specific device. Is it the case?
No. For the cases that we are exploring right now, there's an independent root of trust, which is with the device. The device has the keys. So the certificate chain that is exposed by the SPDM certificate block is the chain that is anchored onto the vendor CA that allows you verifying the signature over the SPDM transcript.
Right. So at a high level, what you are saying is that the keys for that specific device are not available to either the CVM or the platform. It only remains within that device. Is it correct?
The kind of devices that we are looking at, yes, they have independent routes.
Okay, that clarifies me. And how does that key gets provisioned to that specific device? If that remains only within that device, who provisions that specific key to that device?
I believe it's the vendor. Maybe there are other modes where an integrator could do that, but I don't know. In principle, who ships the device?
But that's sort of out of scope from the context of what you've presented, right?
Yes, absolutely.
Okay, thanks. That would be good to have it clarified in the draft, if not already, like what kind of devices, like as you mentioned, that would be that would be nice to have it clarified. So there would be interesting security considerations if that's not the case. Thanks.
Okay.
Okay, other questions? If not, we'll move on to the next presentation.
Okay, thanks very much, everyone.
That's not it. Hang on. Okay, Usama, you're up.
Right. Yeah, welcome everyone. I hope June will be taking the notes now. It's the work that we did, we meaning I, Vyacheslav, and Jan-Mary did recently. And my feeling was that despite having presented in IETF 1 to 4 meeting in RATS, there are still some things which are controversial, which came up later on. So I will be trying to kind of cover that. And with thanks to all the people who are mentioned here, Ecker, Ju, Marcus, Mariam, Tiadan, Yuning, Pavel, Kase. And yeah, next, please. Right. I have two parts to my presentation. First, I would describe all the work that that we did basically, and then specifically for the next steps for my own draft. Next, please. Right. This is basically a quick overview just to give you some context of what this is about and what approach we did for the results that I will show you later on. On the left top, we have these attesters, meaning the layered attester, for example, InterTDX, which has layered structure, provisioning certification enclave, quoting enclave, then enclave on top from SGX perspective, and from TDX perspective, that will be similarly the provisioning certification enclave, then quoting enclave, TD quoting enclave, and then on top that will be the CVM trust domain in Intel's terminology. From ARM CCA perspective, we will have two attesters, one namely the platform attester, the other one being the realm attester. From that, we build the system model that is covering the whole space we expect. On the left bottom, there is this security goals that we want to analyze. And agentic AI is just an example use case. What we want to basically cover from Brad's perspective, you can think of as in a workload which is changing at the runtime. And that basically means things like changes in the workload itself or updates in the platform as well. On the right top, you see a tested TLS protocol, which is basically saying the transport protocol TLS as an example protocol. So it's something we did the proof on. I will show you next on a little bit late that it's not bound to TLS specifically. That is, the approach is more generic, so to say, also for ad hoc or noise or other protocols we can take into account. What's more important is kind of this binding mechanisms and the practical implementations that we have. And based on that, basically, we can form this formal model and then do the analysis. That's the core idea. And from that, we have these relay attacks that I will describe. Next, please. The analysis is done in the ProVerif. That's one of the assumptions that we have. Of course, the tool has to work correctly. And then binding mechanisms. For that, we have here the list of the binding mechanisms that we use. Among those are TLS client nonce. As I said, it can be any protocol that is being used, and it can be, for example, like if it's ad hoc, that will be the initiator nonce. And the specific case we have is TLS server as the attester, meaning that the verifying relying party is on the other side as the client and that's sending the nonce. Then the second option is the TLS, the client's attestation nonce, the dedicated nonce that it uses for attestation. There is something called a re-exporter in the TLS that's specific to TLS protocol. And then there is server's public key. And then there can be the combinations. So these are the first four building blocks or the binding materials that we can use. And then there are combinations underneath. We can combine these basic binding materials, so to say, into different combinations. And 5, 6, 7 are showing that we combine attestation with the exporters, attestation nonce with the public key, attestation nonce with the public key, and the exporters, all of them together. And my question here to the working group for discussion is whether there is any other binding material to someone's knowledge, for example, that we might have missed. Or also a related question is that is there some combination that might be interesting? Of course, like with 4 different materials, there are 16 combinations possible. We haven't covered all. The reason being the attestation nonce is required to prevent the replay attacks, and we only did 3 combinations which made sense to us. That would be interesting, but the point I want to discuss here is that is there something that we have missed, and is there any intuition behind that, the kind of combination that someone might suggest for us to have a look at specifically? Okay, if there are no opinions, I will continue. I have, sorry, not on the same slide, please. I had a few things. So there are some for each of these implementations, for each of these like combinations and the basic binding materials, there are combinations, there are implementations like the Metas AI uses the first one, which is the TLS client nonce. And the thing is that they had an extensive security review recently by the Trail of Bits. But they did not use formal methods, and that's the advantage of using formal methods, that they did not cover all the corner cases that are possible, and that eventually does not give you the evidence freshness because they use the TLS client nonce rather than the specific attestation nonce for that. And one of the drafts actually uses attestation, this combination 5, and many implementations like Edgeless, Cocos AI, CCC proof of concept, they are all using combination number 6. They are all vulnerable, as I will show you in the next slides. One question for discussion I have is there any other intra-handshake implementation to someone's knowledge that we should have a look at, or what we might have missed here? Okay, if not, then I will continue. Next slide, please. Right, so this is a bit of a detailed figure of what the main issue is. I want to make 2 high-level points before going to the details of this whole thing, which is to say, I have the case of server as a tester. I'm combining client party and the verifier. Simplistic case to first start with. Server as a tester, client as verifying client party. As I said, there can be other protocols. If it's ad hoc, it will be responder as a tester, and the initiator as the verifying client party. The thing here is that, of course, we have only verified TLS protocol and have some intuition for ad hoc, as I will show you, but I'm going here for this slide specifically for the TLS protocol, which is to say we have 3 levels of binding. The first one, the exporter, you see on the right side, the first block, and the second block is the handshake traffic secret of the client. And the third level is the application traffic secret, which includes the combinations up to the server finished. So one high-level argument here, or the intuition here, is that if we want to do intra-handshake, we need to present it within that certificate message, unless we add some new message. So to provide it within that certificate message, we have to derive it from the KCH as shown at level 2. And that key, basically, it doesn't include any contribution of the authentication. As you see, the step number 2 is afterwards of what is done in level 2. That is, the server is not yet authenticated. By binding at this point in time, what we are doing is basically we are binding to an unauthenticated endpoint. We don't yet know whether that is really the point, whether that really is the evidence of that authenticated entity that we want to attest. And second point is the relevance that handshake traffic secret, basically handshake traffic secrets from the TLS perspective are used to encrypt the handshake traffic, meaning the messages that you see here, 1C, 2A, 2B, 2C, 2D. So these are all the handshake messages. They are related for privacy. They're not related by any means for security. I removed the encryption of these messages, and all the security properties are analyzed without the encryption that you see in the orange color KSH. All of these encryptions are not in place. It still holds. It has nothing to do with the security properties. The security properties, however, are very relevant for the level 3 that you see down there in step 3, application traffic. At the end of that connection, it's going to send some secret, it meaning the client, And that's really the thing that we want to protect. That might be the decryption key with which the CVM is going to decrypt and start running it, and so on. So that's really the thing that we want to protect. Next, please. And feel free to have any discussion in between if you have any points. If not, I will continue. Yes, right, Kathleen, please.
Just a clarifying question, Osama, as chair.
Yeah. Mhm.
Are you presenting this work for awareness on the SEAT working group? So that, or I may have the name wrong, your attestation working group for TLS? Is this just for awareness? It's not for RATs to consider adoption, right? Because you're talking about attestation within TLS.
Right. I have a specific slide on that specific question. So if you don't mind, I can answer that specifically on that slide.
Okay.
Okay. So I will continue unless someone else has some other question. And hopefully we will come to that slide, which is specifically on this topic of TLS versus SEAT. So the relay attacks that I'm talking about, I presented at IETF 1-4 meeting. The only change here is the TLS nonce replacing the attestation nonce. That was the first mechanism. And the similar thing can happen. Adversary can forward it to a genuine AI agent, which is the agentic thing that we had as a use case. It can get a genuine evidence and present it as its own evidence. The verifying relying party is now going to connect to adversary rather than the genuine AI agent. Next slide, please. It's again an abstraction, meaning that it's not really the trace that we have. The trace in ProVerif is quite large, meaning that the assumption here is that the agentic AI, one of the AI agents, which is the genuine one, if it loses its private key, then adversary can first establish a connection with that specific agent, get that evidence, get its certificate, and then present that evidence in the connection with the verifying relying party intercepting that connection. And again, the situation is that the verifying relying party as a client will establish a connection with a tested channel with the adversary and not with the genuine AI agent which it wanted to. Next, please. And this is the hopefully going to answer the question that Kathleen had. So of course, for this work, I'm not really asking for adoption. What we believe from our understanding is that, and doing all this practice work, is that it's not specific to TLS. Like the two arguments, if you recall that I made, like the handshake traffic keys and the authentication part, it's very typical for protocols that they first do the key exchange part, then they do the authentication part. And in that authentication part, for intra handshake, we have to send that evidence. And we believe it applies to other protocols like attested ad hoc protocol, for which we have a high level, like not as extensive as the one we have done for attested TLS specifically. It's a high level argumentation that we have done and mapped it over to this one-to-one from this proof to that. And we believe that it's a generic characteristic and a fundamental one, security consideration from remote attestation perspective, rather than specifically applying to a tested TLS protocol in itself. So that's the kind of motivation behind this. And it might as well apply to noise too. We haven't done any analysis for that. But just seeing the architecture of how the protocols are built, like key exchange part, authentication part, and then the keys for the other argument, like the security relevance and security irrelevance, is the kind of pattern for the noise protocol as well. So the core problem I want to highlight for security consideration perspective is that the binding of the evidence is to an unauthenticated pair, which meaning for TLS is the server, for ad hoc is the responder, and not specifically related to the TLS protocol in itself. For instance, the relevance to RATs is that the interaction models draft is talking about security considerations. And this is one important thing that needs to be highlighted, that the evidence has to be bound to an authenticated pair and not an unauthenticated one. Deb, yes, please.
So I need you to go back 2 slides to the man in the middle slide.
Sure.
One more. No, you were right to begin with. Sorry, Ned. So ahead one. So this is a classic man-in-the-middle attack, correct?
Right.
Okay, so go ahead, one more slide.
But
And this is an
just-
attack, pardon?
But just to clarify, from attestation perspective, we are saying that it's using TLS nonce as attestation nonce. That is the difference from a typical man in the middle to rats specifically.
Now go back one more. So it is still a man-in-the-middle attack. You
It
still
is
have an
still man in the middle.
adversary in the
Yes.
middle.
Yeah. Right. Correct.
that's- Right? So go one more
Yeah.
ahead. Sorry to go back and forth so much, Ned. So this is, in this circumstance, your genuine AI agent, or whatever you're calling the,
Yeah.
what I would call the client or the recipient, would be, is leaked his private key. So
It
in the
has
case of
leaked
leaking
yeah.
the private key, it's game over, right? Then anybody can masquerade as him, which is what you're doing here.
Not really, because you can prevent this in the case when you have the attestation key still not being leaked. You have two keys from.
Once you've leaked your private keys, you've leaked your private keys, correct?
Yes, but you. That's the whole point. That having two roots of trust means that if you lose one of the keys, for instance, your private key, as long as the other key is not leaked, the protocol design should still protect.
So you have
The whole
two private keys
security
here? Is that
problem.
what you're saying?
Yes, that's correct.
So you've leaked one private key, but not the other.
Right. Yeah.
So which private key have you not leaked here?
Attestation key.
But you've leaked your actual TLS, because you are actually talking about TLS here. You've actually leaked your TLS private key.
Yes, that's correct.
So in most cases, when you've leaked your private key, anybody can, whoever's got your private key can pretend to be you. We call that masquerading. And at that point, it's sort of game over. I mean, I guess you can talk about attestation being separate, but the channel itself is insecure. Yeah, that's a good question. So in the chat, there's a question that says, what's a suitable scenario that one private key is leaked and the other one is not? And it might depend on where those keys are stored, I suppose, where one of them is out and about in the device and the other one is in a hardware that you can't get to.
Sure. I mean, they can be both even in the hardware, and that might be different hardwares. For example, one is TE, one is HSM. They might fail independently. It's one might be in TPM, one might be in TEE. They might fail independent of each other. So I would say that is still a realistic scenario that is possible and can happen independent of the two. Like they might not have a dependency that if one leaks, the other one necessarily leaks. Does that answer your question?
Yeah, sort of.
Okay.
Thomas is on the queue.
Oh, yes. Regarding the impact on the reference interaction model document, I think section 942 already talks about the fact that the parties need to be authenticated in order for impersonation to happen. So at a very high level, this is already taken care of in RAIM. Just
All
noting.
right. Yeah. I think it needs to be more clear, I would say. But I will then propose some specific text for that.
Have a look, because that's a high level document. It's not necessarily targeted at the TLS, so
sure,
it needs to be high level.
Yeah. Sure, I will have a check. Is there Thomas? Is there any other question from your side? Okay, Yukshan.
Yeah, hi. So could you go to the next slide, please? So I see here you have the mitigation to use post-handshake attestation. So I
Mhm.
also wonder, like, what do you think of the mitigation by adding the transcript hash in evidence?
Transcript hash. Okay.
Yeah.
So, Ned, if you please go to the slide I had with the devil thing, so that might be. Uh, so the
Which slide? What number?
so I think it would be 4. Uh, one forward. Yeah, this one. So which one? So which one? Which transcript hash? Um, at the point in time, for example, like if you want to send intra handshake, what will happen is that you want to send it as part of to a message certificate extension, right? So the best you can do from transcript hash perspective is to include um, the log EE, like the 1C message, like the first, it's still not authenticated at that point in time. The authentication starts from the certificate message itself. So, but what's concretely your idea? Is it like defining a new exporter as was done for the tested TLS draft? Is it what you are proposing, or are you proposing something else?
Actually, I'm just curious, like, why do you think like adding the transcript hash in the evidence is not enough? Like, why it cannot mitigate the relay attack?
Okay, so that's basically, I think so there are two problems here as highlighted in this slide. So even if you do, let's imagine the case in which you do that. The thing is that um, it's not still really doing what it's not really protecting the real secret, which is shown at the step 3. Even if you include that even if you include that transcript hash, right? So you protected your handshake messages, and that we prove that has no security relevance. It's for the privacy perspective that a person in the middle cannot get any information about what you are exchanging, like what's in the certificate message and what kind of encrypted extensions server sent over and so on. But it actually does not give you anything about the secret which is sent in the step 3. And that's the point I say as the relevant and the irrelevant part.
Mm-hmm.
And the second argumentation is related to the authentication part. Even if you add that handshake transcript, it's not yet authenticated. That part is related to key exchange part, like the log E is the point which you will encrypt, and that will not fix the problem.
Okay, so because for me, I understand that the relay attack is because it lacks the channel binding. So
Mhm.
I don't know why we need to protect the secret to resolve the channel binding attack. Like for me, if we add
Mhm.
something that is session unique, I think it can somehow bind the channel. Like I don't see why protecting secret is the solution to bind the channel.
So hold on. So when you say I think I agree with you when you say something unique to this to the session. But the point is that it's insufficient. For example, if one of the keys leak, as I mentioned in the next slides, like the one of the keys leak, then the whole security argument breaks. The security property that we want is that even if one of the keys is breaking or is available to the adversary, it should not be able to do any harm. The other key, like the whole point of argumentation, let's go back very top level. Why do we want to add attestation? I mean, that probably also was Deb's question to kind of add on that. So the whole purpose of adding attestation is it should provide better guarantees, right? If by leaking one key your security still breaks, then I would argue what's the whole benefit of doing this attestation thing? And it's not really bringing in any benefit. The whole benefit is that hey, see, this key is broken. Let's say the TLS was broken. I still have another root of trust, which is still not broken, and I still continue to do a communication which is still secure. And if the other one breaks, let's say attestation breaks, and it does break. I mean, I don't agree with the argument that it's one is stronger than the other. Like look at T.fail, YTAP.fail, and so on. Many attacks, foreshadow, and so on. So both keys can leak independently. The property that we want is that if one breaks, the other one does not break, and the whole security still applies. That's the kind of property that we have. Does it clarify your questions?
I think it's quite a general answer, like not very specific to the channel binding property. But yeah, I think we can discuss more maybe in the IETF.
Okay, sure.
Yeah,
There is a
thank you.
detailed email that I sent over, so you can also have a look. I sent it over to the lake as well, I think, and many other groups, I think. So yeah, we can have a chat at that thread as well.
Yeah, for sure.
Thanks.
Yeah, thank you.
Net, please.
Yeah, so you mentioned earlier you're going to tie this back to RAT's security considerations. Did we cover that material yet?
Not yet. So that's the second part. So if you go back to slide 7 or 8, I think is that part is going to. Yeah, right. I think I covered this one. So the mitigation is post handshake. When it is authenticated, you bind it over. One of the keys leak, it doesn't break your security. Next, please. Okay, so that basically is the next steps for the draft. If you go one slide next, please. Right, so the kind of discussion now for that specific draft, what I want to have is I want some clarification from the working group and the chairs and the AD as well, that the way I view the RATS charter is in two forms. From a security perspective, of course, that's what I'm looking at. There are many other things. For me, I see it at two levels. One is the format, one is the protocol, and I have two ideas which I sent it over on the list as well. One is to say I cover in this specific draft a baseline that, let's say, interaction models says that, hey, this section 5.3.6 of this draft applies, and the mitigation provided in section 6.3.2 of this draft that we will have like is the way as the mitigation. The pro that I have written here is the shared burden, that the working group continues to work on their expertise. I continue to work on my expertise. And the way we merge it together is that, okay, so this is what comes out of the formal proofs. And this draft kind of covers all these results at a high level. Of course, I will not put all of these formal things into it. I will just link to the papers that we will have. The idea is that at high level, this idea one will give you the baseline that other drafts can simply point to by saying that in security considerations, look at this section. This is the relevant to prevent relay attacks, let's say replay attacks, and to prevent, I don't know, like the diversion attacks, and maybe something else comes up later on. And for mitigations correspondingly, so this releases the burden of the authors from that perspective. The idea too is I provide only the guidelines in this specific draft, and that might mean something like from our formal analysis, we believe that a draft should cover, let's say, 1, 2, 3, 4, 5 things, and then authors take the responsibility that a kind of a checklist or something that they take as a starting point, and they say that yes, we have covered that, or no, that's not relevant, and that would be my kind of point for discussion, that whether the working group likes to have the baseline or the guidelines, what would be more interesting, and what's the thoughts of the folks here. So any opinions on this? Yes, please.
Okay, so I'm just going to jump in here. So the question, I guess, to the work group is there value in having a document for which the authors of drafts can point their security consideration sections to say, yeah, this other document has the security considerations text that I would normally have included in my security considerations section. Option one. Option two is, hey, there's a document that provides some context and background for how to write good security considerations. Read that first and then write your security considerations section. Like, is that the correct summary?
Yes, that's perfect summary, I think, which covers exactly what I want to. I will just add, I think there is RFC, whether it's, I have written it in my draft, I forgot the number, probably it's 3442, which is like kind of general. And for attestation, I believe we really need something else. It's the kind of general protocol is not valid. I have some arguments in the draft latest version. So yeah, I would like to hear thoughts.
Okay, Deb.
So my opinion, and without a hat, I guess, so not as my AD hat, is to not do the first one. I have, with a hat on, I have seen many drafts with Yang in them that have security considerations, which are very boilerplate. And I don't really want to see that happen in the security area. So if you want to publish guidelines, and this is specifically for rats, not for anything else, that you could do that and encourage authors to look at the guidelines. I would use them as a jumping off point, not as a checky box list thing that you need to do. If you want to see what Yang does, I think it's 8407 BIS is the draft they're working off of now. They have a web page that basically gives you the current security consideration text that you have to post into your drafts. I'm not a fan.
Okay, thanks.
Fine.
June?
Next in the queue.
June, I don't hear you.
Hello, you can hear me?
Yes.
So I have two comments. So the first comment that such kind of guideline will become a single point failure because it will represent the opinion of one small group of people, not the larger group. And the second thing is that
wait before
I
you
have
before,
not. You can let me finish my speak. The second thing is that for other working groups, I do not see such kind of documents. So meaning that for the security consideration part, so each document has its own considerations. So actually, you are like to create a superset for that. And you are saying, okay, so for the problems that outside this set is not considered a problem. So I do not think it's appropriate method to work like that. It's a good way is that, so if we have already the security consideration from all existing documents, like the documents are already accepted by IFC or grouped in a well shape for the working group last call. So we can take that as a good examples. So that, okay, so in all these documents, so what kind of security consideration they are doing, so can give others a good reference. And it's not the method from you scratch it up and to us is what need to be considered in the security consideration. I do not think it's a good method.
Okay, so on your first point, it's not, let's say, if I understand correctly, what you said in what you were saying in the first point was that it's a representation. It's not a representation of the whole working group. Is that a good summary of your first point?
Yeah, the first point is that so it's represent the opinion of a small group of people. So it's not necessarily the consensus of the group. So this is a very risky part.
Right, but I mean, the whole purpose of having this as a working group thing is to get consensus on that, right? I mean, and it's not really.
But you know, the reality is that I think 90% of people does not write anything, that they even do not hear anything, and it means that in fact only a small group of people will have the right to define what is the good security consideration. And actually it is
Mhm.
1% of people who usually work on it will try to give the definition. So this is the risky part. So
Right,
I prefer to do it in a distributed way so that each document has its own security consideration and they try to publish in the working group and people are willing to revise and give comments to their security consideration. So you see
I
that
mean,
it's the way of thinking of these problems in a centralized way or distributed way.
it's not really centralized. I want to correct that specific part. It's not, neither idea one nor idea two is going to be centralized. Idea one is saying I'm providing you a baseline which applies to
Yes, so you
general.
see, this is the baseline. Actually, you
But
see that
June,
this is
excuse me,
the
excuse me,
one
excuse
you
me,
want to define, right?
excuse me, June. Would you please let me finish, please? So I let you finish. So let me finish, please. Right. So let's not make it a mess. So let's go step by step. Let me make an argument first. Let me finish that, and then let's go to you to kind of defend your perspective. Let me also talk as well, right? What I'm trying to say is that it's not a centralized one in a sense that I will provide you a baseline. In idea one, what I'm saying is I provide you general guidelines. Whatever document exists, like for evidence, as I said, the general guidance that exists as of today is that RFC, which I have to look up the number maybe very quickly. So that is only giving you some general guidance. Nothing exists as of today for what the authors are expected to do. And it's no means saying that you will not have a security consideration section. So it's not centralized that you just point to it or just finish it off. That's not the way. It provides you a baseline, as the word baseline says. You build on top of that. It kind of eases your work to say that, hey, this section for replay attacks, see these mitigations, that work has been done already. You don't need to go into all these details because this draft is going to help you cover that part. And whatever general things we learn over time, we keep putting it here. it kind of it kind of assists all the authors in doing that, in saying that providing these baselines, and the baseline will over time become authentic and more understood as we will proceed with it. So that's one point that I want to defend. It's not centralized versus distributed. You still keep your authority, you still keep your, let's say on what you as authors want to do for your draft. It's not overriding by any means any of your authority. It's providing you or kind of helping you do the thing that you need to repeat in every draft. It's kind of building that baseline or bottom line. And I want to very quickly describe also your centralized point from idea 2 perspective, which is saying I provide you the guidelines. You are free to kind of just ignore that. It's meant to be what I would view as something that needs to be covered. What I have seen over the documents, having several of the documents missing commonly in all or most of the documents, what I have seen not being covered, and it kind of frustrates me that it's I have to repeat every time for each draft. I think it's the better way is that I do it in a draft, kind of cover that, and the authors see whether it's relevant or not. You still keep your authority. It's not centralized.
I will say that one thing that you can publish in your blog, there's no problem, or you can submit to some journals so that there will be some peer review. So the risk is that, so you can edit this document and you are the own authors for that. And so you see, it is not peer reviewed and endorsed. If it's name of the rats, it's for others who will see that, okay, it is
But
endorsed by the rats working group. So this is the risky part.
wait, so when you talk about peer reviews, so I want to say that there are a number of papers which are already referenced in the text. So peer reviews to me will mean two things, like is it the peers at the IETF or is it the peers meaning the peer review at the top security conferences and journals and so on. It's already referencing all the papers, like Asia CCS is one of the top security conferences. We have a paper there. So you can't really claim that it's not reviewed by the peers. And the whole purpose of bringing it here is that you get to, I mean, you as authors get to contribute to this draft. It's not my draft. It's going to be the working group draft. That's the
So,
whole purpose of
so
this.
I'm gonna jump in. Thanks, folks. So there's been some interesting threads in the chat. Given that seem to be going down the path of option number 2, folks in the chat are also suggesting that it needs to be more of a living document. So maybe, something like a wiki. Let's continue that discussion on the list. We've been letting this conversation go a little bit long just because I haven't seen our next speaker, David, show up. So we're sort of giving him some time to show up. But if I don't see him here, if he's here and muted or silent or something, please speak up.
So I'm going to dial back a second to the point on the security considerations. We had that discussion at the last IETF meeting. Usama said unless he doesn't remember it. I will go back, or if somebody else has time to go back and look through the recordings. I provided very specific guidance, but Usama was also taking minutes. So it might have been too much for him to take in the content, perhaps. The guidance given then, and I think others who have been around in the IETF for a while are in agreement with this, because I'm seeing it in the chat, is twofold. If there are gaps in security considerations in existing published RFCs, the way that can be handled is with an updates document. And you just put in proposed text that gets added into specific portions of the document, and the documents get linked in the data tracker once published. And obviously it goes through the consensus process to get to the point of publication.
So that's maybe, so sorry to interrupt. So that's the next slide. So Ned, if you go to the next slide, please. So I divided it into 3 different parts. So I don't want to, one back. There was a slide in between these 2. Yes. So I divided it into 3 parts. So I think when you talk about, or it's actually my fault that I talk about 3 different things in the same draft. So which is quite maybe messing up different things. But I think what you are talking about is this. And one question I have specifically, which was not answered yet, even on the list, is, does the working group and do the chairs want me to write one update draft for each RFC, or is it one draft which updates all the 4 RFCs? That's one point which I'm stuck on to move for this.
I'm going to say do one document, and Deb can overrule me, of course. One document, we'll start with one for all 4, because we're not doing a biz.
Okay.
Right? So you're not getting a biz document for each of those.
Mm-hmm. Okay,
so we'll start with that. And if it makes sense to break it out, because there might be cases where you're going to say this particular text updates this document, and this document, and you list the sections and where the text gets added. And then we can set up space on the wiki, as discussed previously. On the mailing list, you didn't seem to understand this. So I'll say it again, and then we can go back and find, the recording part that had provided this guidance. A wiki for including a template that can be used in any documents as a guideline to include security considerations to make sure things are addressed. And those can be flexible, because like if you look at the Yang one, there are sections that get modified specific to each draft and the protocols in that draft. But if there are standard things that should be included across all the documents, the wiki is the right place to do it. And then people would cut and paste in that content and modify it as appropriate for the specific document. And so this was discussed at the last meeting as well.
Right, but I don't remember that we had a consensus on that.
I will find,
of course.
Oh, we don't need a consensus call for that.
Mm-hmm.
It's a standard practice. So I'll go back and find the recording if it helps you. If this doesn't ring a bell to you, it might just be that you were trying to take minutes at the same time, but I also had a conversation with you following the meeting and went over this a second time.
Okay, but I don't think people read wikis a lot, but yeah, okay, I get your point.
Osama, it's a standard practice. And so as chairs, Ned and I would make sure that the template was used. and security directorate reviewers would have awareness of the template and would know to refer to that template, because not all of the security directorate reviewers will be familiar with RATs. And so this gives them guidance in terms of what are they supposed to look for RAT specific documents, and eases their burden. So it will be used. This is a standard
Okay.
practice. So we're not special.
Right, that
Deb?
makes sense.
So whether you do 1 update or 4 updates is going to depend on exactly what the overlap of the updates is. There are cases where we allow 1 update for multiple documents if it's a common update across the 4 documents and it's well documented why you're doing this. It's allowed. If the updates are in fact different for each document, then we will want those to be separate.
So there are no specifically common things except in 2 drafts. That's pretty much different. So what I'm getting from you is that I need for issue based rather than RFC based. If that issue is common across 2 drafts, I write it based on these issues.
So you're going to have to write it down and look at it, and then we'll decide whether to split it or keep it the same. Like, it may not be able to say a priori ahead of time which way you should go, because it may depend. There is some cases in Jose. There's some cases in the past where we have asked authors to split the updates into pieces, and then there are some cases where we are allowing updates to be all together.
Hank?
Yeah, hi, this is Hank. So I'm not super familiar with updating updating documents. It's late here. But will we assess if the problem is an actual problem somehow? Because I'm not entirely sure to do this, to be honest, and I'm asking everybody. It's a whole group here.
Hank, so Hank, great questions. This would all go through the working group. So the template and update documents, they're not going to go through unless the working group thinks they should go through.
And to follow up on the point that Deb was mentioning, I think it's already written down, at least in some parts. All of the 4 RFCs are a part of the draft itself. So I would encourage the group to have a look at that. And I mean, in the last meeting, one of the authors himself came to the mic to say that, yes, he agrees with this. So I don't see any disagreement on that, Hank. So if, as one of the authors of the draft of these RFCs, you think that you disagree with that, please write it on the list or let me know what you disagree with, because I haven't.
So if there's a simple issue, it is the process to go work with the authors of the draft. So you can raise it, like go to their GitHub page, raise an issue, bring it to their attention, and let them, talk about it. That's where it starts, and then from there it finds its way into the working group, where then we decide as the RATS working group what's the best way to disposition it. If it turns out that there's a body of security considerations that are unique to attestation that everybody needs to know about, let's put it in a wiki. But even then, if it's a wiki, we will then discuss the content of the wiki and go through some sort of process where we get consensus about what belongs in the wiki. If there are considerations that the authors are not even aware of, that means there's a broken process somewhere.
I mean, it's a part of my draft. I don't see why it should not be aware to the authors. So all of the 4 RFCs
but your draft is an individual unadopted draft, so we don't expect all of RATs to have read it. And if you have an issue, raise an issue, follow the process.
Okay, but that's very confusing to me. It's an RFC, so I should still write it as an issue in the GitHub of that RFC. Is that correct?
It would be filed as a RATA for a published RFC, and then it would get reviewed in time, which Ned and I would have to spearhead that process. So that's the process for published RFCs.
Okay, now I'm
And
very
then,
confused.
and then I approve them and finalize them as verified. So it's a process. It's a process that has to be done correctly. You've filed errata before that have not been done correctly, and so I've denied them. So try again.
Okay, so I'm
Thanks, Deb.
hearing a lot of things. I'm confused now. So I'm hearing that this has to be done in GitHub issues. I'm also hearing that this has
Nope.
to be done as, okay, not in GitHub issues, only as errata, but for errata, I have to have some agreement of the working group. So where does the agreement start? I mean, I have provided a starting point.
Anyone can file an errata, okay? You don't have to
Mhm.
have agreement on it for you to just file it. It's not approved when you file it. If you would like to do it with other people and file together, that will make your errata stronger. Then Ned and I and document authors will be flagged when this issue is brought forth if Deb says it's formatted correctly, and then we will confer and figure out if the errata is approved. If it's approved, then it gets attached to the document in a state where it will be held until there's a biz draft, but it will be approved so that any implementers of the document would be aware that that is part of the standard now, what's been correctly put forward.
There's a separate
Okay.
process for drafts. So in your talk, you mentioned some of the other drafts that had, security considerations, questions. So the process for the drafts, as opposed to RFCs, is file an issue and work with the authors to get their drafts written correctly before they go to RFC.
Right, but still we had discussions around the update documents. Is it saying that we now are not going for update documents? We are going for issues filing as errata. Is this correct?
Deb, go ahead.
So if it's doable in an errata, it's quicker and
Mhm.
easier because it's just you write the errata, the working group says, yeah, that's right, and then I go and verify it, and you're done. So that's the quickest and easiest option. If you think if it's not possible to do it in an errata, it's too big of a change, it's too, I don't know, whatever, then you need to write an update draft, and you need to work that through the working group, get consensus through the working group, and you go through the entire IESG process before you get an update to it. So that's a much, much longer process. RFC editor queue time right now is at best 12 weeks. So your update won't be out for a long, long time. Whereas you can do an errata today, and if the working group agrees that it should be verified, I can have it approved tomorrow. So those are your two choices.
Right, thanks.
Okay, I think people are ready to move to the next topic or to close the meeting down. And I don't see that David is here yet. So
No, and I dropped him an email, so I did try to reach out.
Okay, so
You have Hank in the queue? Hank,
Yeah,
do you
Hank
want to
has
be
been
in the queue?
for a while.
I'm just patient and polite. But I think the issue, so to speak, has already resolved. While I was trying to look at GitHub and often found an angry unicorn looking back at me, I at least could see that the Reds architecture GitHub is archived. So in any case, that would have been a barrier. But I think we agreed not to use issues, so this might be moved. But I just wanted to highlight, if that becomes an option again, it is not guaranteed that the GitHub repos exists or are unarchived. Just as a highlight for the notes.
but that's an already gone to RFC piece of work, right?
Yes.
Yeah.
That's
So
true.
different
And
process,
it's not
different process
guaranteed
for
that
different documents. Yeah.
Yeah, and it's not guaranteed that you have a GitHub repository for your document. It's not required. In Reds, it's typically very common. So I think that's not the issue.
Yeah. Okay, I think we're done. unless
Thank
you have
you all.
anything, Kathleen. So thank you
No.
again
Thanks.
to the notes takers. We really appreciate the work that you do. That helps us all a lot. So thank you very much for that. And thanks everyone for attending the RATS virtual interim. We will, however, cancel the meeting for tomorrow. We don't have topics that have been lined up for that one. So we will not be meeting tomorrow. So thank you.
Okay, and we can try, before we close, we can try to have one more interim before China, assuming that that would be helpful. So maybe if we put that like 2.5 weeks out and just get another poll out, I think we'll have lower numbers in China, so it might be helpful, especially with this additional bandwidth, right? We allowed conversations to go on a little bit extra today for a good reason. Hallway conversations really won't be as easy in China. And so some of the higher bandwidth we got today was likely helpful.
Okay, thank you.
So if you're going to have another interim, it has to be before the 1st of March.
Okay.
Or I
All
get
right.
in trouble.
Okay, so we'll get that in place. Thank you, Deb.
All right, thank you.
Thanks, Ned. Thanks all.
Bye. Cheers.
Thank you. Bye.